note, I always find it very useful at the start of the question to draw this diagram. So the number on top, just like with coordinates, the first number is our left and right movement. The second number that you see in your vector is the movement up and down, so in your y-axis. If it was a positive number, it would be moving to the right, negative left, and for the second number, if it's positive, it would go up, negative go down. If you can remember that picture, it's going to help you, especially when drawing or using vectors for transformations. So in this first question, it asks us for 2f. If we were to draw out this vector f, we know that our vector has started at this point, it has moved 4 places to the right, and the second number is positive 1, so it has moved up 1 to our new location. So if we were to draw that out as a straight line, it would look like that red line there. It's then asked us to double this. So again, we've got 1f here. If we did this exact same thing again, it would move across 4 spaces to the right and up 1. So then again, if we drew a straight line connecting those together, we now have a straight line, not drawn accurately, but representing 2f. So in total, if we have a look at what we have done, we have moved a total of 8 spaces to the right and 2 spaces up. So our new vector would be 8, 2. Now I wouldn't recommend drawing that diagram, but that just gives you an insight into what's gone on. So actually for 2f, all you have to do is double both of your numbers. Similar thing happens for f plus g. All we've got to do is add our top numbers together, so 4 plus 5 is 9, and add our bottom numbers together, 1 plus 3 is 4. So that tells us that this vector would move 9 to the right and 4 up. Our final question, we've already got 2f in part A, which is 8, 2, and we are subtracting g, 5, 3. So again, if we drew this out, you would end up with a vector which is moved across by 3, 8 take away 5 is 3, 2 take away 3 is negative 1. So just remember, that would mean that our vector would move 3 to the right and 1 down. Question 2. It's asked us to work out the vector of this translated shape, a topic which you would have previously done. So what we need to do is work out how we have moved from one of the corners to that exact same corner of the new shape. So all we have to do is count how many it's moved to the right. So it's gone across 1, 2, 3, 4, 5, 6. So it's moved across by 6 and up by 3. Therefore our vector, translating the shape from P to Q, is just 6, 3. And this is where it's quite useful just to remember that diagram I showed you earlier. So whenever I have a vector question, I would draw that vector diagram straight away. Again, very similar, just please make note of which shape is moving where. So we're going from shape P to shape Q. Again, I have just picked out one corner. Make sure it's the same on both shapes. So it's going to cross by 1, 2, 3, 4, 5, 6, 7. And this has moved 7 to the left. So if you remember that picture, that would be negative 7. And it's moved 1, 2, 3, 4 up in the positive direction. So again, we have our left-right movement on the top, our first number, so minus 7, and then our up-down movement as our second number, so it would be minus 7, 4. Our next question, again we're looking at a translation. shape P is translated to shape Q. So we started at P, we have ended at Q. So again we count the squares. Make sure you again pick the same corner to see how much it's moved. So it's gone across 1, 2, 3, 4. So 4 to the right is positive 4. And this time we have moved 2 down. So therefore it would be minus 2. Our next question. So this is a tricky shape. So again, please make sure you are extra careful when you select which corner you're going to look at. I'm going to go for the bottom left-hand corner of this shape. We're going from shape P to shape Q. So again, I count how many it's moved. It's gone once, twice to the left. So if we remember that picture, then we know it would be minus 2 because it's gone 2 left, and it's gone down by 1, 2, 3, 4. So moved down by 4, so it's negative 4. So question 6, they've drawn the vector onto the isometric grid, and they've asked us to work out what C, D and E are in terms of A and B. Well, like I showed you earlier, A is this horizontal movement left and right. So if we look at C first, we can see that actually you can fit on 3 A's. So therefore our vector is just 3A. The reason I've underlined that vector is because I cannot write in bold. So if I underline it, that shows the examiner or yourself that that's meant to be a vector. So that's C. Part D, a little bit trickier. We have to come up with a route that we can work out what the vector is. So I know my starting point is here, my ending point is on the cross. So if I went up 1, I know that that is exactly the same as this vector B, because it is parallel to the vector B. Then I also know that it's moved across horizontally 1, which is exactly the same as my vector A. We do have to be careful and just double check they are going in the same direction. So therefore, my final answer for D would be B plus A, and it doesn't matter if you've written this as A plus B. The general notation is to write it in alphabetical order, however you wouldn't be marked down for this in your exam. Our final one, probably the trickiest one, part E. So again, we just need to be able to work out how we've gone from our starting point to our end point. We can move across, which I already know is this vector A, and then we're going to move backwards down to our ending point. Now just make note that this is actually going in the opposite direction of B. We're travelling back. So in order to show that, it would be given as a negative B. So here would actually be negative B. So therefore our final vector would be A minus B. Question 7. Again, it's always helpful to try and draw a diagram if possible. So if I've started at this shape R, it's told me that it's moved 4 to the left. That's that minus 4. And it's moved 1 up. And that has got us to the point S. It now wants us to work out how to get back to that place. Well, if I wanted to reverse this, I would need to go 4 to the right and 1 down. So therefore my vector would be 4 minus 1. So my answer would be D. A little bit of a hint or a bit of a cheat to use is actually you'll notice that the signs have just swapped over.